Hey Algebra 1. So for today's video, we're focusing on histograms. So this is the 11.3 video 1. We're going to learn how to make a quick histogram. Mostly we're going to do these on the calculator, but we'll do one by hand here. And then start to learn how to kind of read and describe a histogram. So we're going to start on binder page 379, if you want to pause and get to there. On this screen here, you can see an example of a histogram. It kind of looks like a bar graph, but for a histogram, the y-axis is always frequency, which means how many data points. So if you look at this histogram, whoever they were asking, it's all about their ages. So we could see that there's 2 people who are between 20 and 30 years old, 4 between 30 and 40, 4 between 40 and 50, etc. Okay. All right, so let's start on page 379. What we've got here is a table about the number of glasses of water you drink per day. So 0 to 1, 2 to 3, 4 to 5, 6 to 7, 8 to 9. And they surveyed a bunch of people, and we can see in the frequency column how many people answered for each category. So what we're going to do is turn this into histogram. And it talks about starting at 0 with a bin width of 2. That's what it says in step A there. Okay. Well, the bin width of 2 is referring to each of these categories here. 0 to 1, 2 to 3, 4 to 5, 6 to 7, 8 to 9. Because those are each 2 glasses of water wide. 0 or 1, 2 or 3. Okay. So what I want you to do is take your x-axis, we're going to label it number of glasses. And we know we need 5 categories, so we're going to kind of split the x-axis into fifths. So 1, 2, 3, 4, 5. And what we can do is label each of those with the bin widths. So 0 to 1, 2 to 3, 4 to 5, 6 to 7, 8 to 9. Okay, now our frequency, let's see, we want to look at what our values are. We have 10, 42, 35, 27, 8. So we're going to need to get all the way up to 42. So maybe we could count it by 5s. So let's go 5, 10, 15, 20, 25, 30, 35, 40, 45. It was a little too high, but that's okay. And let's actually label them 5, 10, 20, 30, 40. All right, so then to create our histogram, what we're going to do is make the bars for as high as it needs to go for each bin. So the bin is like 0 to 1, and in 0 to 1 there's 10 people. So we make a bar at exactly a height of 10, like that. Then for 2 to 3, we go all the way up to 42. So that's going to be just a little bit above that 40 tick mark. Okay. Since we're making a sketch, this certainly isn't going to look perfect. We're going to have little wavy lines here. 4 to 5, 35. So we'll find 35. And then 6 to 7 is 27. So a little less than 30, more than 25. And finally, 8 to 9 was 8, so less than 10. Okay. So there's our histogram. One thing I think can be helpful, especially if you're making a little sketch like this, is to actually put a little label on top of each bar with exactly how many it's meant to have. So I can call this 10, 42, 35, 27, and 8. That way you know exactly how high each bar is, how many people are in each one. All right, so in order to answer this first question here, describe the shape of the data, we actually need to grab something from the previous page. So I'm going to input this here. We've got this picture here of symmetric and skewed distributions. You can find it on the previous page. But basically what it is 3 ways to describe a histogram. And we say we're describing the shape of the histogram. So the 3 choices are skewed left, symmetric, or skewed right. So when you describe it as symmetric, it's because the shape of the histogram is pretty evenly spread out. There's most of the data in the middle, and then it tails off pretty evenly on both sides. Okay. For skewed left and skewed right, that word left or right describes kind of where the tail is longer on the histogram. So if you can see in that image there, skewed left means we kind of have a tail off to the left side. And most of the data, the higher bars for the most part, are on the right. Skewed right means the tail goes off to the right and most of the data is on the left. So for this problem here, our histogram that we just made, we would describe this as skewed right because we have a higher peak over here on the left and then it tails off to the right. More of the data is on the left than on the right. So we would call this, like I just said, skewed right. Okay. Now, to answer a few questions here, let's see. How many people drink 6 or more glasses of water? Well, that would be the 6 to 7 people and the 8 to 9. So that would be 27 plus 8. So that would be 35 people. How many people drank 7 glasses of water? Well, you might think, oh, let's just look at this 6 to 7 bar. But that doesn't tell us exactly how many drank 7. We just know that there's 27 people that drank either 6 or 7. So for here, we don't have enough info. And part E, what bin contains the median number of glasses of water? Okay, this is a little bit of a harder question. First, we need to figure out how many total data points there are. So if we add up 10, 42, 35, 27, and 8, I believe you get 122 people surveyed. Okay. Well, the median's the halfway point, right? Well, what's half of 122? That would be 61. 61 is half. Okay, so we gotta figure out which bin the 61st person approximately would be in. Okay, so I'm gonna start on the left. I'm gonna add up 10, and 42 makes 52. Well, that's not 61 people yet. So the median can't be in the first bin, 0 to 1, or the second bin. Well, 35 gets me, what was that, 52? So that'd be 87. That gets me past the halfway point. So that means the median has to be in that 4 to 5 bin. So we would say the median is in 4 to 5 glasses. Okay, that was our first histogram problem there. Let's do the example 3 here at the bottom. Use the histogram to that shows the test scores on a recent physics test. True, false, or not enough information. Well, part A, 15 students are in the class. To help me answer this, I'm going to actually go label the histogram for myself. So the first bin has 1 student, and then 2 students, and then 4 students. I'm looking at the where the y-axis hits the bin. 5, 2, and 1. And if you add those all up, that's 15, I think, right? 1, 2, 7, 12, 3, 15. So 15 students are in the class, so that one's true. More students earned a 49 to 50. Well, let's see, 40 to 59. That's the first 2 bins, so that's 3 total. And then 60 to 69 is the third bin, which is 4 total. So more students earned 40 to 59, that's false. More earned 60 to 69. Part C, more students earned 70 to 79. Okay, 70 to 79 is 5. Then any other 10% interval? Yeah, it's the highest interval. Yeah, that's true. The range of test scores is 60. Well, remember, range means something very specific. It means max minus min. And on a histogram, we don't actually get any specific data points. I know the maximum is somewhere between 90 and 100, but that's all I know. So I don't know what the range is. So this is not enough info. The range might be 60, but we don't know. Average test score was 70%. Here's another one we don't know. The histogram doesn't tell us the mean. So this is not enough info also. Okay, we're going to jump ahead. We're going to skip a page. We're going to go to 381. Just talk about this for a tiny bit. On this page, it sort of summarizes a few key ideas when we're talking about histograms. So part of what we're going to be doing is kind of interpreting what a histogram tells us. And so we're going to be looking at measures of center, measures of spread. So center is mean, median, mode. Spread is standard deviation, range, IQR. And we're going to focus on shape as how we kind of decide how we describe the distribution, the histogram. So we've got this chart here at the bottom of this page about is the data symmetric, yes or no. When it's symmetric, that means there's not really any outliers. And if there's no outliers, then that means the mean and the standard deviation are pretty good. So we'll use those when there are no outliers, when the data is symmetric. If there are outliers, that's the second kind of section here. If there are outliers, that means the data is skewed, either skewed right or skewed left. So in that case, the mean and the standard deviation are going to be affected by those outliers. So instead, we use the median and the IQR because the outliers don't impact those. But today, we're really going to be focused on just deciding, is the data symmetric or skewed? Okay. So skip now ahead another page to page 383. So on here, we're just going to finish up with these 4 histogram examples. And we're asked to describe the shape of each using terms like skewed left, skewed right, or symmetric. So if you look at these are histograms for individual players during the 2013-14 NHL season. We've got the first one is about shooting percentage, then number of goals, then number of shots, and then the time on ice. So our job is to describe symmetric, skewed right, or skewed left. So first I want to pick kind of the obvious ones. If you were to pick one that was obviously symmetric, I would say it's this bottom right one. Okay, definitely very evenly spread out from left to right, so we call that symmetric. We also have a couple obvious skewed ones. Here on the top right is definitely, it tails off to the right there. So this would be skewed right. I think you could say the same thing about the bottom left. You can see this section down here, it definitely tails off to the right. Another thing you can notice is that there's definitely more data here on the left. All these histogram bins on the left are much higher, so we say this is skewed right as well. The one that's a little tougher to tell is the top left. I think you could argue for either symmetric or maybe skewed right, because you've got off to the right there, you've got this kind of extra long tail there. There's some from 16 to 18 to 20, even a couple in that 22 and 24 range there. So you could make an argument for skewed right, but at the same time, it is pretty symmetric. So I think I'm going to go with symmetric. Because this tail is so small, it's really, I mean, like this side here balances out pretty well with that side there. So symmetric, you could go skewed right. There's definitely some interpretation involved. Okay, that's all. Thank you for watching.